Hello, everyone. Thanks, everyone, for dialing into the webinar. We still have a few participants trying to dial in, so let's give them a chance to tune in, and we'll start in a couple of minutes. Good morning, good afternoon, good evening to the people dialing in from around the world. My name is Ling Ng. I'm the Director of Communications and Marketing at I4E. So I'm pleased to welcome you to the brand new showcase series organized by I4E. So the showcase series will bring together, will bring our members one step closer to potential collaborators by giving them the opportunity to directly showcase their products and solutions. So I'm very happy to kick off the topic of the first session of the showcase webinar, which is on productive use of renewable energy and industrialization. This edition is powered by our member water kiosk, who you will meet in the panel. Dear audience, kindly note that the session is recorded, and recordings and presentations will be made available on our website. Next slide, please. So this is the agenda of the day. So as mentioned, you have myself doing the opening remarks, after which I'll be handing it over to our colleague, Rebecca Brigant, our board member. She'll be the one facilitating the panel discussion. And in the hot seat, we have 4 of our distinguished I4E members. We have Laura Corcoran from AdTech Africa. We have Dr. Hamed Beheshti from Water Kiosk. We have Bob Carnell from Smarter Microgrids and Ulrich Zimmermann from Zimpatech. Now, this is an interactive webinar, so if you do have any questions that you want to ask the panelists, feel free to make use of the chat function and pose your questions there. There is a 20-minute session dedicated to that. And to finish off, our board member Ian Monroe will be giving some of the key highlights from the discussions that we've had with the panelists. Next slide, please. So about I4E, for those of you who don't know us, we're the Alliance for Rural Electrification. We are the global association for the decentralized renewable energy industry. So we're here to catalyze the private sector in helping them deliver sustainable electricity services, thereby creating jobs and powering equitable green economies. We are the oldest and the largest DRE association. We are represented by over 185 members from over 55 countries and spanning 3 continents. If you do want to learn more about us, we have a matchmaking platform on our website, and you can discover our members there. So where do our members come from, and what kind of expertise do they have? As mentioned, in our previous slide, our members work in the 3 continents. So 86% of our members work in Africa, 55% work in the Asia Pacific region, and 39% in the Latin America and Caribbean region. Our members work on all renewable energy technologies, so be it bioenergy, whether that's small hydro, small wind, power components, energy storage, or PV, you name it. We are technology agnostic, and the same goes for systems as well. So our members work both on standalone and mini-grid systems. And I'll finish off with the I4E membership services. We have 3 service lines, and that is the first one being market intelligence and business development, the second one policy and advocacy support, and the last one communications and marketing. So if you do have any questions on how to join the I4E family, feel free to reach out to us. We'd be quite happy to take your questions. and discuss further. And so without further ado, I wish you all a very insightful webinar, and I hand the floor over to my colleague, Rebecca.
Thank you very much, Ling. So yeah, dear I4E community, dear friends and supporters of renewable energies, and of course, dear esteemed speakers, also from my side, a warm welcome to the first ever webinar of our new Innovation for Electrification series. My name is Rebecca Brigand. I'm the board member of I4E and also the co-founder of Pineberry, who's also an I4E member for sure. And yeah, it's my great pleasure to guide you through 4 exciting pitches from our valued I4E members. They will present their recent innovations and success stories to us. They're all related to productive use of renewable energy and industrialization. After the pitches, we will have 20 minutes of question and answers, where you as an audience are invited to ask your questions to the speakers. Also, little reminder, please feel free to post them in the chat already during the presentations so you don't forget about them. And please also name the panelists you're addressing. And we will collect then all the questions and use them in the Q&A session. And then finally, my fellow board member, Ian Monroe, will close with a short wrap-up and some remarks. So now before we start, I would again kindly ask the speakers to stick to the 7 minutes time for the pitches, just so we be sure that we have sufficient time for everyone to speak and also for the Q&A session afterwards. So yeah, without further ado, let's start with the first pitch. I would like to hand over to Ms. Laura Corcoran, who is the Chief Business Development Officer at AppTech Africa, and she will be talking about the role of solar energy in Africa's industrialization. So please, Laura, stage is yours. Laura, are you there? I think we cannot hear you. Laura, are you with us? Okay, it looks like we have some technical issues. Okay, let's give it a few more seconds. And otherwise, we will just switch to the next presentation and then get back to Laura at a later stage. Okay, so yes, then Laura, please try to reconnect. We'll hear from you later. Then next, I would like to hand over to Dr. Hamed Beheshti, who is the CEO of Water Kiosk, and he will present us a showcase of a success story in the decentralized water sector in East Africa. Please, Hamed, stage is yours.
Hi, Rebecca. Hi, all. That's a pleasure, for sure. That's a pleasure to me. So what I would like to present today to you is the story of Water Kiosk and how in Water Kiosk we try to bring a more aspect of renewable energy into the everyday life of people. Mainly, let's talk about our experience in East Africa, and then you can imagine practice it in many other different parts of the world. So this specific case is considered, we can go to the next slide, please. This specific case is considering a decentralized challenges that in many remote parts of the world, even let's say sometimes not really remote, off-grid communities, poor urban communities, pre-urban communities are facing with. A decentralized problem of water, energy, food, sanitation, that not necessarily they get the same support from the solution providers. From one hand, we have drinking water. From the other hand, we have farming. Boreholes for farmers are turning saline. From the other hand, we have malnutrition. That is a part of the farming, part of water that it turns saline. And then we have sanitation problem. And on the sanitation problem, also we have hygiene problem. That it's, we are facing with a chaos of different type of problems problems, while the renewables as a driver for development, power as a driver for development, not necessarily is considering all these challenges of sanitation, hygiene, farming, malnutrition, water, and energy at the same time. Many times we see that renewables probably is just taking one side of it. In this presentation, I would like to present this solution and this performance that we brought to all projects, all in 11 countries that now we are active. So this is a affordable, simple solar water desalination system that is bringing the practice of productive use of renewables into reality. You see, from the left side, we get the raw water from whatever saline source, whatever polluted source. Then we do a pre-filtration. Actually, bringing water is by solar energy. Pre-filtration, again powered by solar energy. And then the desalination in places that there is a need for desalination, water is polluted by minerals, again fully powered by solar energy without any need of diesel or whatever source, even no need of battery. Then up until this part, renewables is to power a machine. Then it comes to the distribution of drinking water. So you see where water kiosk is jumping in, getting that water into the market in different format of refills, ATMs, water distribution by pipe, by trucks, or etc. But this is again, two pieces of the problem and challenge in remote communities is met. Let's go to the better ones, or not the better one. Let's go to another challenge, malnutrition, farming. You see, we connected all machines into farming sector, into vertical farms, efficient vertical farms that they are just demanding 95% less water than normal farming. So the same water that from one hand it goes for drinking, powered by solar, the same farm also getting the same water, but it's added nutrition into water for farming. And again, the entire process of pumping is managed by solar energy. And then you have wastewater from the desalination systems. It goes for fish farming. Then you have algae farming that is used for feeding the cattle, feeding the fish itself, and fish also receive the fish tanks are receiving the entire oxygenation, circulation, disinfection, everything 100% powered by the same machine and 100% managed by the same machine. So this is what we call it a productive use of renewables. Actually, one piece that is missing in this illustration I'm having with you is the sanitation. Part of the wastewater, which is a crystal clear water, but just saline, goes into toilets, goes into washing stations, goes into places that people even wash their dishes, wash their hands, feet with that wastewater because it's crystal clear. It's free from any bacteria, from any viruses, just a saline. Perfect water to wash. This is what we call productive use of renewables in off-grid communities. We can go to the next slide. Here, exactly. So all what explained, it brings the scattered, decentralized problems that they are not connected into one ecosystem of problems and solutions. So water for drinking, for irrigation, sanitation, food, energy, it's all supplied by what is all powered by what is called renewables. And then renewables is the overlap between all of them because it's powered by them, by renewables, but it's not limited just to a light, just to a charger. It's covering the entire, let's say, most of the challenges that rural communities are struggling with. Next slide, please. So in this illustration, I'm not sure how good you can see the details because this illustration is full of the details of productive use of renewables. This is actually illustrating all activities in East Africa. So from the arrival of the machines, from the installation of solar panels in different types, you may see it in this illustration. You can find it in our website as well. You can download it. Into the water distribution, into fish tanks, irrigation systems. Actually, this picture is illustrated out of real photos of our projects. And even at the heart of the picture, the center of the picture, you even see that in some of our projects, we are installing biogas system. The biogas system receives water from the machine, and then the water helps with the digester, and then the gas is used for running cooking stoves. Next slide, please. The next slide is just, a visual presentation to you of some pictures of the project. So these are the way that our projects look like. You see the bottom right one, you see exactly the solar array on the top. Next slide, please. Here in the next slide, you see the farming, the vertical farms, drip lines in the remotest part of the planet, and it's fully powered by the same machine. Please, next slide. The fish tanks, these are the simplest fish tanks receiving the wastewater of the machine. Oxygenation in the top right picture, you see the oxygenation pump is working. Again, fully powered by the same solar array. Next slide, please. And then simple, easy, young operators are able to run, operate, manage, fix, and solve a big part of the problem in their community. So the young teenagers you see there are the ones running the machines and operating them. You can imagine this is a capacity for the future of the work. Here you see another illustration of the solar panels and the whole aspect of the project, and I'm at the end of my last slide. I'm just finishing that. Yeah, so we see here there are pictures, there are applications that the locals are operating. I'm done with it. I hope you had a good understanding of one water solution powered by renewable energy and solving not just one problem, solving a range of problems of local communities in the rural part of the world. Thank you.
Thank you
I'm
so
more
much.
than available for any questions, any comments, anything, and feel free. Pleasure.
Thank you so much, Hamid. So I think all the panelists are, of course, open to all your questions, dear audience, even after the session. So yes, thank you, Hamid, for sharing your insights and this very holistic ecosystem you've built up. So next, I would like to hand over to Mr. Bob Carnell, who is the Director of Business Development at Smarter Microgrid. And he will share with us insight on the productive use of micro-hydro renewable energy for local economic development in rural Nepal. Please, Bob, stage is yours.
Thanks, Rebecca. First slide, please. So I'm going to talk to you about what we're doing in Nepal. We're doing similar things in other parts of the world, but I'm going to talk this afternoon about the way we use our smart microgrid controller for the productive use of the micro-hydro sites in Nepal. As you can see from the agenda on the right-hand side of this first slide, I'm intending to cover quite a lot of things, so you get a comprehensive view of this kind of project. Next slide, please. So one of the most important things to us trying to do these complex projects is that we need some partners where these projects are happening or intending to happen. In this case, our partners are the Nepal Energy Foundation. They cover the socio-economic parts of the project, and CAPEG, who cover the electrical and electronic engineering parts of the project. I'm trying to do these types of projects even close by are complicated enough. You can imagine trying to do them halfway across the planet in very remote areas is challenging. Next slide, please. So just to give you an idea, this is Kathmandu, just to the right of this picture, and Bhutal, which is just to the left of the picture. That's 280 kilometers west of Kathmandu, through the Himalayan foothills, so it's challenging, it's remote. You might just see Mount Everest on the right-hand side of that picture to give you some idea of the kind of challenges we're talking about. Now, these sites we chose in Nepal and others in places like Myanmar in the Andaman Sea, because they are so remote, because we wanted to test ourselves and our partners, our hardware and our software, that we could do these complex projects in these remote areas. And just to give a quick thank you to ARE, not only for this webinar, but because the NEF and CAPEG actually contacted us through our contact details on the ARE website. And I'll also just briefly mention that it would be great if all of you could send me an email in the next day or two after the webinar to talk about possibilities for us to communicate. You can see a bit more about Smarter Microgrid and my contact details on the ARE website. Next slide, please. So these are the two places that we're talking about today. Jumsacola 2, Jumsacola 3, as you can see, it's 30 kilowatts and 68 kilowatts of microhydro. They're a couple of kilometers apart. Jumsacola 2 comprises about 260 consumers, and Jumsacola 3 is about 530 consumers. Next slide, please. This is the powerhouse in Jumsacola 2. You can see the penstock pipe coming in on the left there, driving the microhydro turbine in the blue casing. We will always connect some of our devices to measure the generation of the turbine, obviously, but also in this particular case we have some temperature sensors as well. I'll come back to why we have those later on, but it's to try and extend the use of the turbine instead of having to switch it off a couple of times a day. Next slide, please. So I'm not going to go through all this technology, but this is a diagrammatic representation of the smarter microgrid. I'll just mention a couple of quick things about it. First of all, the devices across the top, they can be wind turbines, solar panels, dump loads, batteries, consumers. They can also be external sources of data, so it could be economic data or weather data and so on. And probably the most important thing that the smarter microgrid controller does is take all of this data and integrate it into dashboards and reports and alerts to enable local operators, local communities, even local government in some cases, to better manage the microgrid. And it's kind of based on what used to be regarded as a McKinsey mandate, I think, which is you can't manage what you don't measure. And that's really the central thing that the smarter microgrid brings to consumers and communities, measuring all these different parts of the microgrid so that they can be managed better. Next slide, please. So this is an example actually from Jumsacola 2, a part of their dashboard. The green bars on the top of the dashboard, as you can see, are showing the energy generation per day for the last month or so. And you can see, I think it's the 7th and 8th of February, where the turbine was switched off for work purposes, maintenance purposes. And then the day after, we added a large load to it to see what would happen. And as you can see from the chart there, about 4 to 5 times as much energy was generated with that additional load, which is a good sign at the beginning of the project that if we can start to work out different productive uses with the local community, then the microhydro generator will be capable of supporting them. Next slide, please. The overall goal, as it usually is in these projects, is to minimize the LCOE and also maximize the capacity factor. And certainly if we're using extra generation for productive purposes, we can do both of those at the same time. Next slide, please. So one of the most important things for the productive use is the socio-economic development that brings to local communities. And most of us, maybe all of us, will have read the World Bank reports about at least 200,000 communities like this around the world, who, if we bring distributed renewable energy to them, can use it for economic development purposes and also in particular for introducing and sustaining programs for, especially for women, economic development. Just one other quick thing about this program that NEF are working with us on is it starts with a baseline study. We implement some programs, and there's an endline study to see what's worked and what hasn't. But also that then creates a new baseline, so it's an ongoing socio-economic development program. It's not just a one-off. Next slide, please. The particular Jumsacola 2, Jumsacola 3 socio-economic development programs, the baseline of which has already been done, includes all the usual things, as Hamed was talking about in terms of water and all of that, but also lighting and cooking, and also women's programs, which have very little economic activity at the moment, but will be developing rice milling and woodworking and tailoring. Next slide, please. So just one final point, as one would expect, is that teamwork is very important, especially when you're doing these complicated projects halfway across the world. And so we do use an online project management system for that. And the final slide, please. So just to thank you to our team from NEF and CAPEG, some of them you can see there, Jamsicola too. And thanks to ARE for managing and organising these webinars. And I look forward to your emails about how we can work together. Thanks very much. Over to you, Rebecca.
Thank you so much, Bob, for your contribution. It was a very exciting presentation, and I'm sure very interesting for the audience. So, yes, next we will hear from Mr. Ulrich Zimmermann, who is the Chief Operations Officer at Sympathec, and he will talk about DC-SHS-based productive use concepts and the importance of plug-and-play AC-SHS. So please, Ulrich, welcome. The stage is yours.
Perfect, thank you. Could you go to the next slide already? Great. Yeah, so this is actually the topic for today, because we talk about productive use, and I think for most people in the mind, you don't directly match it with the solar home systems, because they mostly come from, let's say, smaller size perspective, 2 lamp systems, or even less Pico systems. And therefore, I think it's even more important to stress this topic a little bit. And this is actually what we do. We build bigger solar home systems in many, many ranges. And for that, maybe go please to the next slide to explain a little bit about us. So we are Sympathec. We are a German solar home systems company, and we are already in the field since roughly a little bit more than 10 years. We started more in the Latin American region and are now more and more expanding also to the African region. And we basically are a B2B company, so we manufacture, but this is where we then finally stop. So we are not acting as an implementation company. If you go now to the next slide, I think that shows why solar home systems are so important. If you look really on like productive use concepts, if you look on farms, if you look on decentralized applications, this is a picture of Uganda, you can directly recognize, okay, the homes are also very distributed. So it's really about basically you have different needs and you need to fit them with a solution. Because maybe one farm might need to power a small mill, one farm might need to power a refrigerator, and maybe some others only need light. So therefore, it's really a big benefit compared to like large scale implementations where it's even very difficult to set up all the wiring to all the remote spaces. And that's why bigger solar home systems are quite attractive. And if we go to the next slide, that's what you can also see from our portfolio, which is actually one of the biggest in the world, I guess. If you also look more on the bigger solar home system side, So if you look from the DC-SHS, which is the second of the left side, up until the right side, you can really see we go up to 2 kilowatt hours or 5 kilowatt hours to really be able to store a lot of energy for such use cases. If we now go to the productive use, that's again to little bit get this again in. It's really about improving DSS, in a long-lasting way. Because if you are able to get beyond the topic of I bring light, I bring, for example, a fridge to a shop so that someone can actually store milk, any kind of drinks or anything, or meat, then you can actually generate more revenue within those communities. And you also, by this, improve a lot of other features. Let it be sanitation, let it be the food situation, and that's visualized quite good on the next. If we look on the first use case, when we talk about food conservation, we actually came up with the DC-SHS 25 or 50. We even have a bigger system, the LSDC, which is also currently being in the first installations and also being on the rollout. It's a big benefit, because with those bigger systems, you can basically work on use cases. Yeah? So if there is a fisherman, yeah, who wants to store fish, and they might only need 2 fridges, then you can bring it to a remote place, you install it, and this can happen in a very, very fast way. Still, especially the case about refrigeration, it's not so easy as mostly thought, yeah? Because those refrigerators mostly take a lot of energy compared if you now use a DC fridge, which is energy efficient. Still, there is one big topic that we actually came up together with a partner from the refrigerator space, because we actually created a dual load output, yeah, so that the fridge will always have a dedicated load output from the solar home systems, so it will never run out of energy. Yeah, so we dedicate a certain battery capacity, so you're still able to, for example, have your TV, you have light, you have your radio, but it will be immediately shut down as soon as it will affect the refrigerator, yeah? Because for cooling, it's one of the most important things to actually never run out of the actual temperature. Yeah? And therefore we came up with that solution, which is quite beneficial, yeah? Because it strengthened the whole use case. And by this you can cool fish, you can cool milk, you can use it in a store. So there's a very wide range of application, starting from 50 liter up to 400 liter of capacities, depending on the actual use case. If we now go to the next slide, there is a nice case from our partner Vata, which have quite a big portfolio on systems for actually creating clean water and disinfection materials. Yep, a topic which is especially nowadays very, very crucial. And yeah, because you need to imagine, yeah, let it be a fountain. Yeah, you might have a first cleaning of the fountain when the bore is done, but after a while, if you take out the water, it will get or it can get spoiled again, and therefore having like smaller systems also being able to create clean water, yeah, for hospitals or disinfection materials for hospitals is quite a big impact, yeah, because especially if you think how those hospitals mostly look like, or rural health centers, actually having disinfection materials can already really strengthen those users. And we actually also came up here with the possibility to have paralleling options on the load output for our system. So yeah, so depending on the use case, you can also grow it so that, yeah, depending on the application, you can simply use 2 systems to actually be able to run the use case. So if we now go to the next slide, because as it is mentioned in the title, it's not just about the DC systems, yeah, because DC systems are very, very good, yeah, because they are very energy efficient, but at a certain size, yeah, you already need AC, because if we talk, for example, about hospitals, it's quite difficult to actually run them solely on DC. So if we go to the next slide, or maybe, yeah, there are some pictures from health stations, from offices, from UPS solutions. So if we go one slide further, and I think that's actually quite a good slide to end with, because I think one of the really important thing is that the appliance manufacturers and actually solar home system manufacturers or solution manufacturers like us need to collaborate further, yeah? Because if we are able to better understand the use case, yeah, we are able to align, and we are able to make the use case even stronger, even more cost efficient. Yeah? So thanks a lot. I think my time is now up, and I would hand over to the next person. If you have any question, I think there is the email address, or simply contact us via the website.
Thank you so much, Ulrich. What a powerful message in the end to get into partnerships and collaborate, which is basically one of the main tasks we pursue at I4E. So yes, thank you very much for your presentation. We will now try to get back to Laura, since we had some connection issues with her in the beginning. Laura, can you hear us? Are you with us? Okay, that looks good. I can see you.
I am with you. Sorry about that. We have some people from Paula. Yeah, good to see you.
Great to see you. Welcome. So just a few seconds until we, yeah, here we go. So yes, dear Laura, stage is yours. Please go ahead. Looking forward.
Thank you so much. So hello to everyone. I'd first like to begin by thanking the Alliance for Rural Electrification for inviting me to speak today. You guys are doing amazing work, so we really appreciate you including us in this event. Slide, please. And the next slide, please. So I'm going to first be introducing Aptech Africa. We're an engineering, procurement, and construction company that works in solar energy and water pumping projects. We're headquartered in Uganda, and we operate in 7 countries across Africa, including South Sudan, Central African Republic, Sierra Leone, Liberia, and Niger. We provide complete EPC services, including the assessment, design, supply, installation, and operation and maintenance for renewable energy projects. We provide a variety of solar solutions, including off-grid, grid-tied, hybrid solutions, mini-grids, as well as solar water pumping. As far as size, the largest project we've developed is a 10-megawatt solar plant. Traditionally, we've done a lot of work with UN agencies and NGOs. However, we're moving more into the commercial and industrial sector, which is what I'll be speaking about today. Next slide, please. So across Africa, there's a huge push for industrialization, and this is with good reason. When you look at the economic development of a country, industrialization is what brings more jobs, export revenue, and rapid economic growth that is sustainable. The economic prosperity. That being said, there are a ton of factors that are necessary for industrialization across Africa. Infrastructure in terms of both logistics and energy is necessary. Countries need to create policies that are conducive to local manufacturing, both in terms of investment in import and export laws. Also, as the rest of the world is operating more and more in a digital economy, there's also a need to continue to develop this within Africa. From a growth perspective in Africa, the value of exports has doubled over the past 10 years. So while there's being progress, while progress is being made, there's still a long way to go. Next slide, please. One of the critical factors required for industrialization is, of course, electricity. So Africa has an abundance of all kinds of resources, but this is particularly true with energy. There are 10 terawatts of solar potential across Africa, making solar one of the best energy sources. For myself, I'm based in Uganda, and the government has done a lot to support local manufacturing and industry through their Build Uganda, Buy Uganda policy initiative. Now, electricity in Uganda is more affordable than it is in other countries across the continent. The tariff here is about 19 cents, and this is largely due in part to the national hydro projects, which generate the electricity used in Uganda's grid. But as you travel further into Central Africa, where countries have lower electrification rates and a lack of hydro potential, you'll find some grids rely on diesel generation and can have tariffs as high as 42 cents. These are the countries where solar really starts to make more sense for industrial solutions. In countries like these, there's a huge incentive for manufacturers to switch to solar. It's cost effective, it can provide a source of uninterrupted power, especially in cities where there's load shedding. And of course, the environmental impact. Amongst the sources of energy industries can use in Africa, solar is becoming the preferred source. Next slide, please. So Aptech, as a company, has a long history of delivering community-scale solar water pumping solutions for aid agencies across the continent. This is actually one of our fortes. This is also a prime example of solar for productive use, and almost every industry will require water in some way for production. Most industries will have large warehouses and factories with equally large roofs, also a perfect opportunity for solar. In places like Uganda, where the energy tariff is more affordable, solar grid and hybrid solutions are an excellent way to cut energy bills. When it comes to solar for productive use, a report by GIZ shows that the smaller business benefit from longer working hours, improved quality of productivity, and the attraction of more customers. At the larger scale, solar can be used for running manufacturing plant machinery, with the caveat that some machinery may require a 3-phase system, so low voltage generation will not work under these circumstances. In addition, solar for productive use can lead to increased employment, which can improve the socioeconomic conditions within the community as a whole. Next slide, please. As I've shared, the bulk of APTEC's clients historically have been UN agencies and NGOs. While there's definitely humanitarian needs across the continent, APTEC recognizes that there's a huge gap in the provision of solar solutions for commercial and industrial clients. Because of this, APTEC has expanded its services to bring solar solutions to C&I entities. APTEC believes that this is Africa's time to grow into its industrial potential and is coming on board as a clean energy provider. APTEC's working towards its mission of providing clean electricity and water for people across the continent. Next slide, please. So for anyone out there that might be a solar EPC company, for solar EPC companies looking to enter into the C&I sector, there are several lessons that APTEC has learned that it can share today. When you're targeting C&I companies, this can be as simple as looking for large roof space in major cities or around industrial complexes, or looking for cranes to locate building opportunities. Profiling clients requires a thorough assessment to determine the load requirements and to ensure the system design is appropriate for industry needs, especially in regards to low voltage systems. It's also worth saying that the approach to C&I projects is different. While the environmental impact of solar is very important, for industrial clients, the financial case needs to be emphasized and clearly communicated so that clients can understand the cost-saving benefits of solar. Finally, industrial clients will require upfront financing for solar solutions, so there is a need to bring on board financial institutions to provide a holistic solution for your customers. In order to increase the availability of solar for industries, financial institutions need to focus on financing local EPC companies in Africa, as they are a key part of sustainable provision of renewable energy. Thank you so much.
Thank you so much, Laura. We are very glad to have had you finally in the end. So thank you very much also for your contribution. We have come to an end of the presentations. So once again, thank you very much, dear esteemed speakers, for sharing your experiences, your best practices, your solutions. I think it was really insightful, and yeah, we could just see how versatile decentralized renewable energies can be applied. Also to make an impact beyond SDG 7. So as you can see with you, and I guess there are many other impact makers here in this session, we can see how diverse the portfolio is and how many different concepts there are in the field. So yes, thank you very much. And now, dear audience, it's your turn. So I would like to open the floor for the Q&A session. I would also ask the panelists to switch on their cameras again. So dear audience, please submit your questions in the chat. If you haven't yet, please also address the speaker you're asking the question to. So yes, I think we've already collected some questions, and we will start with a general question from Sylvia Delprat. She's asking, is the development of innovative technologies for productive uses of energy and rural industrialization in emerging markets furnished with localized training programs? If yes, please may you also provide specific examples, preferably from sub-Saharan Africa, and web links to this valuable information. I think we can take care of web links then. So yes, dear panelists, is there anyone who wants to go ahead with some ideas? Please just feel free to unmute yourself.
I can just say from our side, for sure, this local empowerment and local acknowledgement is key, because we are in the remotest part of the planet. Driving from the nearest city sometimes takes 24 hours, reaching there, because it's a rough road. So for this purpose, 2 years after establishment in sub-Saharan countries, we established another entity that is called Water Kiosk Academy. Water Kiosk Academy is a non-for-profit organization based in Nairobi, training whomever that we feel they are a talent in the rural communities. We finance their trip to Nairobi, from East African countries. We accommodate them in Nairobi, and they go through a training, a detailed training of electric, mechanic, and operation by all staff. And then whomever graduates from such an academy, then they are in the priority for us to be hired by our company. We already approached by other companies as well that they send their technicians to our project. So this is our contribution. No project in remote part of the planet is successfully sustainable if there is no training of locals.
Yeah, I think it also that's necessary, but it goes further than that. And what we find is that when we're looking at productive use, I mentioned the woodworking and the rice milling and tailoring and so forth, especially for the women in the community. They not only need training on the microgrid itself and the operation of the microgrid or the water kiosks that Ahmed was mentioning and so on. If they're actually producing new products, where they're dairy products or other agricultural products or tailor products or whatever, they also need to have training and support in building the value chain, the supply chain, to get those from their village to the local towns and cities. And that's equally helpful. So I think when you talk about the complexity of these programs, it goes from the back door to the front door, as people say. And otherwise, if it doesn't enable people to do all this for themselves, including the supply chain at the end of it, where that's relevant, then it's all a bit of a waste of time. Otherwise, it really needs all of that. And of course, the local people need to be trained in all of those engineering and operational and financial and commercial domains, so they can do more and more of that for themselves.
Maybe to add on this also, I mean, we talk even in the baseline electrification. Yeah. So even if we talk about smaller applications, it's always the key to have training. Yeah, to have really the people to be enabled how to use the system properly. And I think that's actually simply multiplied if we talk about productive use systems, because the appliances also have a much more dynamic application. I mean, if we just look on a very simple use case, like refrigeration, it completely depends on what you actually store. Yeah, it completely depends on how you use it. Is it like a fridge that you open once a day? Yeah, is it a fridge where you basically every day exchange completely the inner, or the goods that you have in? It has a completely different effect on how the energy consumption of those systems will be. And therefore, if we talk about productive use, it's even more important to have the local training and enablement.
Okay. Thank you very much. Laura, do you have
yeah, I was gonna say, to add on to that, so for AppTech, we're permanently based locally, and that's one of our advantages. But exactly what everybody's saying, there has to be that capacity building at the local level, because if you do not have people on the ground who can service those systems, it's not sustainable, it won't work. And something to also think about is something that maybe we take for granted is the standardization of technicians and engineers that are trained maybe where we're from. But here in Africa, sometimes those standards are not in place in learning institutions. So when you get new staff and personnel, you really have to train them from the bottom up. So at AppTech, we do both internal and external trainings to kind of build that capacity. And then also, like for these systems, it's also really important to make sure that spare parts are available, as well as the local expertise, because we've seen a lot of systems that one thing goes wrong, spare parts aren't there, and they stop working. So, yeah.
Okay, great. Thanks very much. I think this first question was very well answered from all different perspectives. So we have some more questions. Maybe we just we continue with Laura. So there was one question about how many team members do you have in Africa, and where are the majority based?
That's a great question. So we have about 100 staff across the continent, and they're really kind of spread between offices. Our biggest office is here in Kampala. We have, I think, 33 about there. Yeah, so that's our.
Okay, thank you. Then maybe we continue with a question from Abdallah Baba to Ulrich. What do you think about mobile energy using lithium-ion batteries to the users and mini-grid installation?
I mean, it's now two questions, I guess. Yeah. So first of all, about the mobility topic. Yeah. I think for mobility, it's quite interesting what's currently going on. I think there are many companies working, for example, in the boda space, making, for example, like mobile food vendor stations. So I think there's currently a lot going on. They are a little bit different from what we do, because basically they start normally, I think, at a 48 volt range from the battery perspective. Currently, we go up to 24 volt to have still a little smaller sizes, so to speak. Yeah, I think mini grids. It's always the question. It really depends on the use case. I mean, if you talk about a village where you have 500 people in one place, use a mini grid. Sure, definitely, because then you have one solution which can reach out to all of them. Still, despite that, maybe there are some other people here who could answer that. I think the mini grids are a little bit struggling in the profitability sector, because sometimes it's let's say overestimated about the energy consumption. I mean, I think especially with remote monitoring, there will be in the future better understanding about the actual energy need. But for that, the benefit is simply with the solar home systems, you have a use case, you solve the use case. And by this, basically grow one farm, they can hire more people. And by this, you can also continuously grow such areas. And I think there's a market for both. Yeah, to sum it up like this.
Could I just add, Rebecca, a quick comment to one of the points Ulrich made there, which is, for some reason I don't understand it, it's simulating the generation and the storage and the consumption that one might expect prior to installing or designing a mini grid or a microgrid. Somehow the simulation often gets forgotten, and yet it is very simple to use something like a smart microgrid controller, where you, instead of having real devices driving the data to the microgrid controller, you have simulated data, which is a great way of seeing, well, what happens if we have this sort of solar and this sort of battery and these sort of consumers and that sort of wind turbine or this sort of micro hydro or whatever. And you're actually simulating it, because what we find, and I think is generally true, is that it's a bit too much like guesswork. So you end up with this situation, as Ulrich was alluding to, where when you actually build it and start to run it, you think, actually, we didn't get enough solar, or we didn't do enough wind, or the consumption is different, and so forth. And simulation is a pretty easy and relatively inexpensive way of doing better than just, well, we'll try that and see if that works. And generally you think, we need more solar or less wind or more diesel or less diesel and so on. Simulations, much misunderstood and should be done more, I think.
Thanks, Bob, for adding this important point. So we have another question to Hamid from Jones in Taupira. What's the cost of one complete water kiosk installation, and are there any opportunities for franchise models?
I love the second part of it, the franchising model. This is exactly what we are doing now. So actually we started a franchising model in East Asia. Philippines is the first one, and in Mexico and the other side of the world. So, but yet in Africa, we have not started the franchising model, so it's gonna develop further. It needs resources, but the cost is usually one of the first questions we receive. Actually, there is no price list here. Project by project, location by location, water quality, depth of boreholes, demands. In one place, you may need fish farm. I was just in Zanzibar. There is no need for fish farm in Zanzibar, so it's all ocean. So there is no price list. There is no price tag. these machines and the project both are custom designed. We have project that costed 50,000 euro for covering the entire village economy reshuffling. We have project with €500,000. So, you know, there is not just one figure, but that €500,000 then is covering several villages with huge farms, huge greenhouses, and etc. So what I would say is our customized solution, it comes with customized costing. But
yeah.
just one thing to highlight is we didn't want to invent the wheel again. So the purpose from the first day of our design was, if you check our website, it's always written affordable solar water desalination system. Otherwise, expensive things are in the market for a very long time. We claim that we are the affordable ones.
Okay, great. Thank you very much, Hamid. Yeah, I think we've seen that there's never one size fits all, right? Since we're serving a continent or several continents. So yeah, it's always important to customize. Yes, so then we have another question to Bob from Mewang. As part of productive use of energy, do you also help the entrepreneurs how to develop bank business within the community? Because very often access to finance is a big issue, especially in remote areas. So how much or how do you support the local community to have better access to financing?
Yeah, microfinance is, to be honest with you, we didn't even think of it when we started these projects. I mean, it's obvious when you do stop and think about it. You know, this stuff has to be paid for somehow. But also in terms of the productive use, if you're going to have the power and the energy for women, for example, to start tailoring businesses or rice milling or woodworking businesses, then microfinance is critical. And so, number one, it is critical. You have to have it. You can have all the energy in the world and all the great ideas in terms of entrepreneurial businesses for local men and women and so forth. But if they don't have access to microfinance to get those new businesses started or to expand current businesses, then it isn't going to go very far. And it also goes back to the point I was making earlier. You really need to have everything from the front door to the back door, otherwise, including the microfinance. And what we were lucky with, to be honest with you, in these projects in Nepal, is that the Nepal Energy Foundation, one of their domains of expertise is not just the gender mainstreaming and the socio-economic programs, but it's actually, they have tremendous, especially Dilip Gwame, the director of Nepal Energy Foundation, who contacted us initially through I4E. He has tremendous contacts with all sorts of banking and commercial, as well as federal and local government people. And one thing I didn't expect, which has become very important, is that he is already asking the questions of all those people, including local and national institutions, of where the sources of microfinance could be to help these communities to develop economically. And also in the case of Nepal, that's even more important, because one of the things I had on one of the slides but didn't mention is that these couple of trials near Bhutwal in Nepal are just two of more than 3,500 microhydro installations, all of which need economic development, all of which will need microfinance and so forth. So, yeah, as was shown in India, I think early on, that microfinance, especially for entrepreneurial operations for women, is something that really works. It's not just a moral issue or an ethical issue. It actually works in terms of the economics as well. So, absolutely critical.
Okay, thank you very much, Bob. So yeah, dear panelists, dear audience, we still have many questions, but unfortunately the time is over now. We've reached the end of the webinar. I would kindly ask all the questions that haven't been answered yet, please do reach out to the panelists directly. I think you've seen the email addresses, or you will see them on the I4E website as well, and kindly yeah, follow on with the discussion afterwards. So yeah, once again, thank you very much for being with us on this first webinar. I think it was very exciting to follow your pitches, your presentations. dear panelists, and also this fruitful discussion we have afterwards now. So yeah, I think the topic is a huge has huge potentials. And yes, at this point, I would like to hand over to my fellow board member, Jain, for the closing remarks. So please go ahead, Jain.
Thank you, panelists, for your contribution, and to the audience for the active engagement. Thanks, Rebecca, for the moderation. I thought it was a fantastic and very interesting panel. Hamid, thank you for showcasing the energy, water, and food nexus and how it's so critical to urban and rural communities, and how we can enable all these through renewable energy. Bob, it was very great to learn more about smarter grid controllers and your microhydro scheme in Nepal. Ulrich, the solar home systems in distributed communities is very interesting. I really thought that the cold storage is something for the future for sure, and it's needed now with Zimpertech. And Laura, that was a very fascinating overview on the industrial solar opportunities in Africa. You're right that the financial benefits and the carbon reductions must go hand in hand for these projects to work. The conversations showcasing the technologies, both hardware and software, and the innovative projects highlight how decentralized and distributed renewables can positively impact rural economies and their development. And the ARE members are certainly committed to building a sustainable future in developing communities across the globe. As Rebecca said, please feel free to reach out to ARE or any of the speakers directly to explore potential cooperation and to continue conversations, as I know there was some questions which were left unanswered. Finally, please be in touch with us to find out how you can make best use of your ARE membership and discuss our services and benefits. And if you're not an ARE member, please reach out to discuss this in more detail. I know that there will be a next showcase series in the future. This is going to be on energy storage trends. So thank you very much. Thank you to ARE for organizing, and thanks once again to the panelists, the moderator, and the audience. Thank you, and see you next time.